In this video, we're going to introduce Numpy and look at its capabilities. So Numpy was originally created in 2005 by Travis Oliphant, but over the years, it's now maintained as a Python library, which is open source and maintained by a community of experts. In fact, you can find it hosted on the public platform, GitHub. So if you go to GitHub, you can see this, the official GitHub platform where Numpy is being hosted. Okay, so it's actually used for scientific computing application and also supports large multidimensional arrays and matrices alongside high-level mathematical operations. In fact, one of the fundamental objects in Numpy is its support for n-dimensional array. Sometimes we call this numpy.nd array. Again, Numpy just stands for numerical Python. In fact, this numpy.nd array falls under this class called nd array. Again, we just call this array. Okay, so let's go to the official website. Again, this is the go-to, some of the capabilities of Numpy. As you can see here, you can create n-dimensional arrays, and these n-dimensional arrays provides other functionalities. For example, you can perform NumPy vectorization, indexing, broadcasting, just provides a very fast and versatile way of manipulating those arrays. Also, NumPy is very powerful in numerical computing because it kind of supports a comprehensive mathematical functions. You can generate random numbers. You can also use linear algebra and so on and so forth, algebra routines. Again, one of the features that stand out for NumPy is that it actually is at the core of many libraries and frameworks. In addition, it supports a wide range of hardware and computing platforms, whether you're using distributed systems, whether you're using GPU for deep learning and so on and so forth. If you're using sparse array libraries, NumPy, is agnostic on that end. Again, in terms of performance, at the core of NumPy is a very well optimized C code. This just allows, the Python library, which is just NumPy, to just execute with so much efficiency and speed in terms of the compiled code. In addition, it's easy to use. Again, very accessible and productive for a lot of programmers, whether you're a beginner or at an advanced level. Okay, and lastly here, you can see that it's an open source. In fact, we've already shown you that it's maintained at GitHub, and there are many ways you can contribute to that. So again, here, if you look at the ecosystem for Python, it's used in a lot of these scientific domains, whether you're in quantum computing, astronomy, processes, chemistry, mathematical analysis, and all these are just hyperlinks where you can go to some of these packages or libraries where NumPy is actually at the core. It's just the one that kind of powers most of these applications. In terms of array libraries, you can see that all these are different packages, all these are different frameworks and libraries that, for example, here, TensorFlow and PyTorch, and all these support deep learning frameworks. So they all leverage on the NumPy API and extend this capability, right, beyond what NumPy provides. For the simple fact that it provides all these very nice features. Also, in terms of data science, you can see that NumPy still lies at the core of all this ecosystem. So if you're in the data analytics, where you perform a lot of extract, transform, load, NumPy can be used alongside these different packages to ensure that you successfully perform those workflows. Exploratory analysis, you can use all these libraries, Matplotlib, Seaborn, Jupyter, all this just allows you to visualize your data. And NumPy also helps, in making that a reality. Even in model evaluate, scikit-learn, a very popular, library for machine learning, has NumPy at the core. Same with machine learning. I can see we have several case studies that actually just demonstrate how NumPy is being used. For example, here, let's look at this case study here. You can see here, it's just a quick overview of what's happening here. So this company, Deep Lab Cat Card, is an open source toolbox. So tries to, perform some research, getting the positions and behavior of some of these animals. So you can see here where NumPy comes in. These are some of the challenges: data processing speed, and so on and so forth. But when NumPy comes in to assist in this kind of problems, it performs vectorization in a speedy and efficient manner, has all these functionalities for linear algebra, can perform random sampling array, allows you also to reshape very large arrays of n dimensionals. So again, it would be nice to just go through some of these case studies just to see the power of NumPy, where it kind of just leverages the speed and numerical analysis of NumPy. So, and lastly here, visualization is just something that we've already looked at. Another thing you might want to be interested in is the documentation. So like any other documentation, NumPy maintains a very comprehensive documentation, and a good place to start is here. You just click on that and already provides you a nice documentation for beginners, right? So if you're new to NumPy, it just takes you through how to import NumPy, how to read an example of a code, how to use some of these methods that come with NumPy, differences between list and NumPy, how to create a NumPy, and so on and so forth. In fact, that will be our next video, concepts about basic array, and so on and so forth. You can add, remove, and sort elements. So this is a very nice starting beginner guide for anyone interested in learning a little bit more about NumPy. All right, so again, there's this hyperlink here. Click on that, and you can see also, if you're a beginner, there are quite a bit of curated list of tutorials. And also there's a book here for those who love reading books, and also videos, right? If you're an advanced user, then also there are other different cookbooks and books and tutorials to kind of address that need. And also, if you look at the community here, for example, if you're interested in participating online, you can join this NumPy mailing list. There's a GitHub issue tracker. So, for example, if you want to report a bug, you can always issue that through this kind of platform. So again, it's very well documented here. It's very intentional to allow you to get to interact with this wonderful community. As you can see here, there's you can join them on Slack or attend some of their conferences, right? And then of course here, it has another link here if you want to contribute as an expert. It just gives you some guide on how to do that. And lastly here, you can see as much as NumPy is open source, we still have an organized structure that still maintains, and tries to keep it consistent over the years. So, you can check this out and, read through all this. Okay, so again, that's NumPy. In our next video, we're going to look at how to create a NumPy array.